So I'm going to show you where the sine, cosine, and tangent of the 45-degree angle comes from. Let's just suppose we have a triangle that has a 45-degree angle in it. And we're talking about right triangle trig right now, so this is a right angle. Now, if this one's 45 and we're talking about a right triangle, then this one's 45. And if a triangle has the same size angles in it, it's also going to have the same size legs on it. So that means that this leg and this leg, these two pieces down here, are the same size. So let's just draw another triangle. So that means this is 45 and these two legs across from them are the same size. So let's just pick an arbitrary number. You can pick any number you want to, just you need to make them the same. So I'm just going to use ones. Okay, so if those two legs are ones, and I use the Pythagorean theorem, now I could use 1, I could use 2, and because these are ratios, they're going to come out to the same answer no matter what you do. So if I'm trying to find this missing side here, c squared equals the square of each leg. So c squared is 2, which means that c is the square root of 2. So this is the square root of 2. So let's see, let's check and see. The sine then of 45 would be the side opposite over hypotenuse. And if I rationalize the denominator, I get the square root of 2 over 2. So that's where that one comes from. That's why it's the square root of 2 over 2. If I do the cosine of 45 degrees, cosine is the side adjacent over hypotenuse, so it's also 1 over the square root of 2. Rationalize it, and I get square root of 2 over 2. So sine and cosine of 45 degrees are the same thing. If I did tangent, tangent is side opposite over adjacent. So opposite over adjacent would be 1 over 1, which means it's 1. So those are your three basic trig functions for 45 degrees. And that's why when you punch sine of 45 in on a triangle, you're going to get a decimal that's equivalent to this. If you punch in tangent of 45, you're always going to get 1. So that's where that comes from.